A light horizontal wire of cross-sectional area A is fixed at 2 points at distance 2L apart. The initial tension in the wire is 0. So at the moment, these are in equilibrium, or at least the wire is in equilibrium. An object of weight W is fixed directly to the center of the wire. The wire stretches so that the object rests in equilibrium at a vertical distance of 3L over 4 below the original position of the wire. What is the Young modulus of the wire? So as we're reading this, we need to set up what the picture looks like. So we know this distance is 2L, but commonly I will split this into L and L. This is a very common feature of these problems, that whenever you notice a symmetry, maybe split it into the two parts. It might not be useful, but let's work with this so far. And then we know this part is 3L over 4, and we have a weight W hanging on here. So the wire will develop some tension inside, so T and T, acting at these angles to try and balance out the weight, and then it will rest in equilibrium in this way. So we want to work out the Young modulus of the wire, and we know Young modulus E is stress over strain. And to get both of these parts, we just need to work out the amount of tension in the wire over the area. So how much tension in the wire there will be, so it's T over A. And then we need to divide that by the change in length of the wire over the natural length of the wire, which will be 2L. So writing this, we get T times 2L over A times delta L. So the only things that we really need to work out here are T and delta L. We can get T quite easily because the component of T vertically, which will be 2T times sine of some angle. So if I define this angle theta, this will need to balance the weight, and then they'll balance each other horizontally. Sine theta we can get quite easily because it is the opposite term will be 3L over 4, and then the term for this length we can see is, so if this is L, that's 3L over 4. We can see that more easily as a 3, 4, 5 triangle, because this is 3/4, this is 1. So if we scale everything by 4, we get 3, 4, and 5 for this triangle. So clearly this will be 5L over 4, but we don't really need to work that out. We just needed to work out sine of theta. So sine of theta would have just been 3 over 5. So this means that 2 times T times 3 over 5 equals W. So T equals 5W over, well, 3 times 2, which I know is 6, but I'll leave it as this for now. And then we just need to work out delta L. So delta L will just be, well, what's the new length? This will be 5L over 4, add 5L over 4, because each component will now be 5L over 4. Looking at the diagram, just to remind you, each half will be 5L over 4, which is, again, why I split it into 2 in the first place. So this becomes 5L over 2. A natural thing that some people might do is do 10L over 4, but I encourage you to kind of abandon that habit. So if you see 2 copies of 5L over 4, then you can just halve the denominator instead of multiplying the top by 2. As you get more and more comfortable with fractions, then you'll know what things you are allowed to do that simplify calculations as quickly as possible. So when you multiply by a number, you can either multiply the numerator or divide the denominator by that term. And lots of other tricks that I'm sure will emerge as you do more and more problems. So delta L is 5L over 2, take away the 2L. So this just becomes L over 2. So now putting these in, we get T times 2L, which is going to be 5W over 3 times L. And then we get A times L over 2. We can cancel out the L. We can move a 2 to the top and a 3 to the bottom. This becomes 10W over 3A is the Young modulus. So 10W over 3A, that is answer E. Hopefully this all made sense, but if you have any questions, feel free to ask in the comments. But the main ideas here were to work out, using the geometry of the problem, just the lengths that had changed and the tension that had developed in the wire in order to balance this weight. So either rewatch this, or if it still doesn't make sense, please do feel free to ask questions in the comment section.